welcome back to day number 2 of section 3.3, Proofs with Parallel Lines. Today we are going to do 2 examples of proving 2 of the conjectures or theorems that we learned about yesterday. So the first one we're going to go over says, using a 2-column proof, prove the alternate interior angles converse without using the vertical angles congruence theorem. And they give us a picture here, and they tell us a little bit about the picture. We have 2 lines, G and H, and various angles in here. And they give us that angle 4 is congruent to angle 5. So they've marked that on the picture already for us. And what we need to do is prove that line G is parallel to H. So prove line G is parallel to line H. The first thing we're going to do is start off with that given information. So statement number 1 just says that angle 4 is congruent to angle 5, and our reason behind this is that it is given. From there, take a look at the picture, because knowing those are congruent doesn't really help us with a whole lot. But if we look here, we can see that angle 3 and angle 4 are adjacent angles and they form this straight line. So that means they are a linear pair. So statement number 2, we're going to say that angle 4 is supplementary to angle 3. And the justification or reason for that is linear pair. We can also say the same thing about angle 5 and angle 7. They are adjacent and they form a straight line. So they are a linear pair as well, which means they are supplementary. So angle 5 is supplementary I spelled supplementary wrong up here. A-R-Y. Angle 5 is supplementary to angle 7. And again, we have linear pair. From there, on step number 1, we had stated that angle 4 is congruent to angle 5. And these 2 angles are stated in statement 2 and 3. So what I'm going to do is use substitution and say that angle 4 is now supplementary to angle 7. So angle 4 is supplementary to angle 7. And that's through substitution. And for this I used steps 2 and 3 for the substitution. Let me move this up for you. Sorry about that. So angle 4 is supplementary to angle 7. From there, I have now said that angle 3 is supplementary to angle 4, as well as angle 7 is supplementary to angle 4. So the next thing I can say is angle 3 needs to be congruent to angle 7, and that is because of our congruent supplements. So what we just said is that angle 3 is congruent to angle 7 because of congruent supplements. So because if you look at this picture, we see these as corresponding angles. Now that we have proven these 2 angles to be the same measure, we can now say that line G is parallel to line H. So our last step of this proof says line G is parallel to line H, and that is because of the corresponding angles converse. Corresponding angles converse. Second example that we have says, in the diagram, Line P is parallel to line Q, and angle 1 is supplementary to angle 2. Prove line R is parallel to line S using a paragraph proof. So we are told these two lines, line P and line Q, are parallel. We are also told angle 1 and angle 2 are supplementary, so that means, if you recall, they add to 180 degrees. And we're asked to prove that R is parallel to S. Well, in order to prove R is parallel to S, we probably have to do something with angle 1 and angle 3 here and show that they add up to 180 degrees. So we are going to be breaking this word supplementary down into its definition and getting into the fact that angle 1 plus angle 2 equal 180 degrees. It is asking for a paragraph proof, so instead of boring you with my handwriting for about 5 minutes, I already wrote this proof out. So let's go over it, and I will read it to you and describe my thinking as we go through it. It is given that angle 1 is supplementary to angle 2, so they tell us that. That means the measure of angle 1 plus the measure of angle 2 equals 180 degrees by the definition of supplementary angles. So all I did was take this word supplementary and break it down into exactly what it means mathematically. From there, we are also given that P is parallel to Q. By the alternate interior angles theorem, we can then say angle 2 is congruent to angle 3. So we're looking at R as the transversal to line P and line Q, and the angle 2 and angle 3 are alternate interior angles, so that means they have to be congruent. By the substitution property, the measure of angle 1 plus the measure of angle 3 equals 180 degrees. And we can say that because angle 2 is congruent to angle 3. So I took this angle 3 and I plugged it in here. So let me reread that. By the substitution property, measure of angle 1 plus the measure of angle 3 equals 180 degrees. So angle 1 and angle 3 are supplementary by the definition of supplementary angles. So I just went backwards from what I started with. I took that mathematical sentence and then turned it into a word definition. Because once we have that, then we can say, by the consecutive interior angles converse, R is parallel to S. The last thing in this section is probably something that you're like, duh, yeah, we know that. But we give a actual name to it, the transitive property of parallel lines. It says if two lines are parallel to the same line, then they are parallel to each other. So all that's saying is if P is parallel to Q and R is parallel to Q, then P has to be parallel to R. And that's what it looks like in a mathematical sentence. So that completes section 3.3, the proofs with parallel lines. So we went over some converse, between both days we went over some converse theorems, and then we just finished up 2 examples of proving those theorems, and then defined the transitive property of parallel lines. Thanks for listening, and I will talk to you soon.